Okay, so chapter 4, section 8, we are going to be talking about compound inequalities and how to solve these compound inequalities in different situations that would require a compound inequality. So we'll talk about what an actual compound inequality is here in a minute, but we're going to be graphing the union and intersection of the solution sets of inequalities. So if you remember, inequalities have solution sets. So if I say x is greater than 5, that means it's everything bigger than 5. So there are multiple solutions. Everything greater than 5 would make the inequality true. Whereas if I say x equals 5, there's one exact solution. X can only be 5 to make the equation true. So union and intersection of the solution sets. We're going to see what that looks like and what that means. You are taking your own notes, so make sure that you do get everything copied down that is up here. Don't pick and choose. If it's up here, it's in your notes. So what is a compound inequality? It is a double inequality or two inequalities, and it's connected with the words and or. It might also all be smashed together, and we'll see some of that as well. So compound inequality, just think more than one inequality. So again, inequality greater than, less than, greater than equal to, less than equal to. So we talked about how we were going to be graphing the union and intersection of these sets. So what is an intersection of a set? So if we have two different sets, A and B, it is the set of elements in both A and B. So let's say I have two different solution sets or two different qualities. X is greater than 2, x is less than or equal to 5. So I've got two of them, but I want to know where do both solutions occur, or where do their solutions overlap. So intersections, think both, think overlap. Where do the solution sets overlap? So the symbol is basically an upside down U. To write it, you will see the intersection of A and B is written as A, upside down U, B, but this means the intersection of. So it means where do those solutions overlap, where do they intersect. So what does that look like graphically on a number line? X is greater than or equal to 2 and, so as soon as you see that, that means the intersection, so you're talking about an overlap. X is greater than or equal to and x is less than 6. So if I were to graph just x is greater than or equal to 2, and then if I were to graph just x is less than 6, again, open circle, just less than, closed circle because it's equal to. If I were to graph them separately, that's what it looks like. But this tells me I want to know where do they overlap, where do they intersect, the solution sets. So my solutions occur everywhere from when x is 2 to when x is less than 6. That's what they have in common. So x is greater than or equal to 2 and less than 6. So it's everything in between. This is my solution set for this compound inequality. Again, I have two inequalities. So that's what it's going to look like. So what about the union of sets? Two different sets, so think two different solution sets for us at this point. And it's the elements of the solutions in either A or B or both. But this one, think either. Intersection, think overlap, where do they intersect? Union, think either. So the symbol is basically a U. Notice we don't have a little stem hanging off. So the union of A and B is written as A union B. So what does that look like graphically on a number line? X is less than 3 or x is greater than or equal to 5. So if x is less than 3, it would be x is less than 3, everything to the left. X is greater than or equal to 5, closed circle, and then it would be everything to the right. So in this case, it's either x is less than 3 or x is greater than or equal to 5. Is there an overlap? No, there is no intersection of the two sets. It's either x is less than 3 or x is greater than or equal to 5. And we'll look at a couple of different situations in class in which we would have an or situation occur. Okay. So now, to get into solving these compound inequalities with the words and or. We can break the compound inequality into two inequalities if we need to, and you'll see what that looks like here in a second. And then we solve them just as we do any inequality. So it's the exact same thing we've been doing. We're just saying instead of 1, we're now going to have 2 to solve at the same time. So let's look at the first one. We're going to solve and graph the solution set. So negative 5 is less than 3x minus 8, which is less than or equal to 1. Okay, so see how it's all smashed together here? But notice we have this common 3x minus 8 is kind of what's in common between the two inequalities. We have two inequalities, so this isn't a compound inequality. What we're going to do to solve this, we're going to basically break it apart so it's easier to see and easier to work with, and we're more familiar with it. So I'm just going to focus on one inequality. So I'm going to look at negative 5 is less than 3x minus 8. And now I look at the other inequality. 3x minus 8 is less than or equal to 1. So I have my two inequalities. Now all I have to do is solve both of them just like I always do. So I add 8 to both sides. So 3 is less than 3x. Divide by 3. 1. X is greater than 1. Over here, add 8 to both sides. 3x is less than or equal to 9. Divide by 3. X is less than or equal to 3. So I'm going through this quickly because we've been doing this for a long time now. If I want to write this such that the variable's on the left side, I can. Just make sure you do not change what the inequality is saying. X is greater than 1. Okay? So again, make sure the inequality is facing in the correct direction. So now I want to graph this. So I'm graphing the compound inequality, and I'm looking to see where these solutions intersect or overlap. So x is less than or equal to 3. 1, 2, 3. So I know I'm going to have a closed circle at 3. X is greater than 1. So I know I'm going to have an open circle at 1. Greater than 1, less than or equal to 3. So where do they overlap? What do they have in common? Everything between 1 and 3. So everything greater than 1 and less than or equal to 3. So that's how you graph that solution set. So notice compound inequality. We have two different solutions. You may also see the solution set written as if x is less than or equal to 3, okay, but greater than 1. So you may also see it written like this, which is both of these solutions together. Okay, so if we condense it back to make it look like the original problem. So notice that was an intersection, there was an overlap, so it was an and. Here they're telling us, hey, we want this inequality or this. So it's already separated, so we just solve them like we always do. Get the variable to one side, constant to the other. So I have 5z is less than z plus 4. Okay, so I've got the number on one side, so I want to move my variable to the other. So 4z is less than 4, divide by 4. Z is less than 1. So there's one solution. Or, let's see what else z could be. We want to subtract 18 from both sides. So 7z is less than z minus 18. Subtract z. So I get 6z is less than negative 18. Divide by 6. Z, if I wrote an x, z is less than negative 3. So z is less than 1 or z is less than negative 3. So let's graph this and see what that looks like. Okay, so I know I have an open circle at 1 and I have an open circle at negative 3. So z is less than 1 or z is less than negative 3. So remember, or it's either solution or both. So really what happens, if x is less than 1, obviously, z, if z is less than 1, obviously it's less than negative 3. So my solution set in this case is simply x is less than 1. So either solution set or both. So any value I pick for z less than 1, it will make the inequality true. Okay, so moving right along. Here's another one. Okay. 9 is less than 6x minus 9, and 6x minus 9 is less than 39. So notice where x is smashed. It's right in between. So again, I've got two inequalities. It's a compound. Just look at one at a time. So let's separate it out. 9 is less than 6x minus 9. That'll be one inequality we focus on. The other one will be 6x minus 9 is 39. So now we solve them both just like we always have. Add 9 to both sides. 18 is less than 6x. Divide by 6. 3 is less than x. Go over to your other inequality. Divide by 6. X is less than 8. And again, these are going to be connected with an and. So I got 3 is less than x and x is less than 8. So together, these solution sets are solution sets to this original compound inequality. So what does that look like? Well, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. X is less than 8, so there's an open circle. X is greater than 3. X is greater than 3. So x is greater than 3, x is less than 8. So it's just everything in between. That's my solution set to this compound inequality. So basically solving two separate inequalities, graphing them on the same number line. Once again, this is going to be an and. I've got a compound inequality. Let's separate it out. Negative 22 is less than negative 5n minus 2. So there's one inequality. And then my other one, and negative 5n minus 2 is less than 48. So I solve them both. Number on one side, variable on the other. So I get negative 20 is less than negative 5n. Divide by negative 5. Do not forget, when we divide by a negative, that sign has to flip. So divide by a negative 5, so my sign flips. I'm going to add 2 to both sides over here. So negative 5n is less than 50. Again, dividing by a negative, so what happens to that sign? It flips. Okay, so these solutions together are my solution sets to the compound inequality. So x is greater than negative 10, and n is less than 4. So let's see what that looks like. 0, I'll count by 2s. 2, 4, 6, 8, 10. So I'll say this is negative 10, 2, 4, and this is 4. I'll do it in a different color so it's easier to see. So n is less than 4, and n is greater than negative 10. So greater than negative 10, less than 4 is everything in between. Again, if you want to write it like as the original, put n right in the middle. Greater than negative 10, less than 4, or you could have written the other way, which you probably would be most likely to see. Usually the smaller numbers on the left and then going to the right. So this could be how you would connect these two solution sets and bring them back together as it is in the original compound inequality. All right, so for homework, you are going to solve both of these inequalities and graph their solution sets. Check them tomorrow, and we will continue with this tomorrow in class.